Yes.
Should be happy to use this for my training, or my therapy, I should say.
You're logging your hours. Awesome. Well, I've started recording, and I guess we can get started, and then anyone who had RSVP'd, I'll just send this to them.
Okay.
But thank you so much for taking the time to talk to us. I'm super excited to see you again because we haven't been in the office together. But for Mel, who is a non-VSET member, we work out of Vermont Center for Emerging Technologies, which is a nonprofit innovation hub in Burlington. So I'll let you take it away, Duane.
All right, cool.
Awesome.
Well, thanks, Amy. It's also good to see you as well.
Mm-hmm.
So this workshop, folks, is really, it's covering the basics. And, one thing I want to just throw out there, and I'll mention this towards the end as well, that if you want to see more hands-on, if you want more hands-on, and if you want to do this, personally, just let me know. And, I can show you how this works behind the scenes. But what I wanted to do is show you, talk about the most common things, and then what you can do now to help mitigate those issues. So a quick bio with me is that I've been working in cybersecurity since '97, and I worked for the education sector for 2 years, and then I moved to the federal sector and did incident response as well. Did a lot of secure coding workshops throughout the country for the agency that I worked for, and that was a lot of fun. One of the things that would almost always happen is that after the workshop, or the workshops were over 2 days, so 4 hours, and then we'd come back the next day. But every time I hosted this workshop, folks would come back the second day and come up and say, Duane, I really appreciate the workshop. I went back and looked at my code and tested some of these things and saw that we had some problems that they were able to fix, which was fantastic. Because the way we hosted that workshop is that we took real applications that we found within our organization, and we showed them how those were vulnerable. And that had, a big, I think had a better impact on what's possible and what can happen when we don't properly, we don't write good secure code. I didn't mean to say good code when you don't write secure code. And I've been teaching since 2006, mainly online with my alma mater, Pfeiffer University. And then I switched to teaching full-time in 2012 here at Champlain. And that's where I am now. Sorry. So with some of the vulnerabilities that are the most common or most susceptible to are data breaches, which we see and read about all the time. And unfortunately, these can occur by a single vulnerability or a single lack of validating input in data. There's a web form where someone inputs information and they can either gain admin credentials and get access to a database. People may forget to change default passwords, and which can allow someone access to a database or access to data that's stored on a web server. It doesn't always have to be a database. Arbitrary command execution is probably the most dangerous because it essentially turns the application into a shell, where from a web browser or from an automated program, someone can execute any commands with the permissions of the user that runs that system. And in cases where they elevate their privileges, they could then potentially gain access to other systems within a network, or crawl the file system and look and find other sensitive information. And of course, the nightmare is a compromised local computer, because that could lead to someone gaining access to other computers in the organization. And when you have a mass compromise, that's when you have lots and lots of problems. And it's a lot more difficult to clean up, and it can cost a lot of money to clean up as well. So what I hope with this workshop is that you learn some basic things that you can do to mitigate some of these problems. And I'll start right away by just simply saying you filter input and you encode output. And I'll talk about this more and show you some examples of how this can be done as we move along. So what I'm going to do first is just talk about some of the most common vulnerabilities, and then we'll look to see how you can test to see if you're vulnerable to them, and then we'll look at some more input validation techniques. SQL injection is one of the most well-known, and it's probably one of the, I would say, last major vulnerabilities out there. Because, you know, most of the cyber attacks that we hear about occur as a result of well-known attacks. And SQL injection occurs when someone is able to control the database queries using the form on the web page, or they use an automated program that will probe a form to look for vulnerabilities. Because again, it can be one form element that may lack input validation, and that's how they can gain control and enumerate a database. And the query you see on the screen, or 1 = 1, validates to a true statement with SQL. And I'll show you how this works in just a moment. So one of the first things that attackers may do is simply input a single quote into a form, and then see, how does the web server respond to this? How does the application respond? And in some cases, they'll even see an error message. And you can see with this error message here, this 1064, that the MySQL server is what's on the back end. And this is an enumeration attack. They're trying to enumerate, they're trying to figure out what version of the database backend is, so they know how to tailor their attack. For one, it reduces their footprint and reduces noise as well. So if you look in your web logs and you see that someone is filling out a form and they have a single quote in a lot of those fields, they're probably trying to test to see if it has a SQL injection vulnerability, or they could be mistyping it, the values as well. So in this case, the database backend is known. Now they can tailor their attack, which is why I have these two queries here, because the dash dash, that's a comment with a MS SQL server. This # is a comment with a MySQL server, and I'll show you why that's important. So here's a query where someone is typing in the username and password, and they're going to select from the table where the username equals administrator and the password equals, you know, some hash password. That's how the query should be passed to the database. However, what happens with a lack of input validation, and I'm using PHP because that's the programming language for the web that I'm most familiar with. In this case, they're taking the variables, username and password, straight from the form, and they're passing that directly to the database query. And this is very, very dangerous, for the reason that a user could input arbitrary code or arbitrary values. In this case, the username is administrator, and the password you see is this single quote, or 1 = 1. And then this #. So the query would be passed to the database as we see here, but it would be passed in based on what we see down here. And we have two vulnerabilities essentially. One is the password is more than likely stored in clear text. And I know this because if this works, that means the password is not being hashed. Because if it was being hashed, this string, or 1 = 1, would be a MD5 string or SHA string, etc. So this is already a vulnerability. But you can see from this query that it says select username from table where username equals administrator, just replacing the variable here, and password equals, this evaluates to nothing because you see these two single quotes, or 1 = 1, which is true. So this becomes a true statement. Anything after this will be ignored because of this # right here. That's why you'll see some attackers include this # so that if there's any other queries or any other SQL statement after that, it's going to be ignored because the user, the attacker, is controlling the query. Users should never control the query unless you have a web form where they can insert SQL queries, like phpMyAdmin, for example. But for authentication, that should not be the case. However, if the password is hashed, the attacker will generally know that. So they try a different form. In this case, here's a good example. Here's administrator, a single quote, and then this pound sign. So it's passed to the database like this. Select username and password from table where username equals administrator. The queries after this, the statements after this, is completely ignored because of this pound sign right here. MySQL says, oh, this is a comment, so I'm going to ignore this. I'm just going to evaluate this part here. So if the username equals administrator, they'll authenticate, which is a very easy bypass and a very, very dangerous bypass because the administrator typically can control various aspects of the application. And feel free to ask questions at any point if you want to as well. So SQL injection prevention, I'm going to come back to this later on as well, but I meant to take that slide out, so I'm going to jump ahead real quick. So how do you test with SQL injection? Just like I just mentioned, one, if you have a web application, or not just a web, but if you have a thick app, insert a single quote into every form field by itself and see what is thrown back to the user, what's on the screen. Sometimes errors don't always appear on the screen. It doesn't mean they can't enumerate the database. If you have a tool such as SQL Map, it's able to enumerate automatically. I highly recommend tools like SQL Map and to integrate it into your development process. So as you're developing your code, you can run SQL Map periodically to see if you forgot to or if you've got to filter input. It's a very powerful tool. When results don't appear on the screen, it's what's called blind injection, meaning they won't see the output appear within the web browser or on their console, but tools like SQL Map have ways to probe to figure out and enumerate databases. It essentially enumerates one character at a time, but it does that extremely fast and gets the results pretty quickly as well. You can also save data into a file and then download it via the website, for example. Cross-site scripting, another very common vulnerability. And this is where, again, the user is able to control the flow of the application, and they're able to inject, in this case, malicious tags of some sort. The first two, for example, are JavaScript. The first one just says hacked. It's more of a nuisance, if anything, because every time you load the page, you just see this pop up that says hacked. And of course, it still means it's vulnerable by all means. The second one is even more dangerous, because if this tag, script document.location, if this gets saved into, let's say, a web forum where you're communicating with other people. If this is saved to a database and then presented to the web page, you're never going to see that web forum. It's going to immediately redirect you to this malicious domain. And this could have a malicious Java applet. It could have a malicious JavaScript code or something that could download to your computer, and you wouldn't even know it until a few minutes later. This is something that happened quite often when I was doing incident response. When we're interviewing the person who was impacted, they'll say, well, I was surfing the web and then I was on CNN's website and then these pop-ups happened. Well, it's probably not CNN where they were hacked. It's because they were downloading or looking at other websites previously. And when we go to collect their browser history and we did our analysis, what we would see are things like document.location or this iframe, malicious iframes. And iframes in this case are dangerous because you see this width 0, height 0, you won't ever see the iframe on your web page. Especially if the web page has a bunch of content, has a bunch of images on it, I almost guarantee you, you'll overlook it. It'd be like this little teeny tiny square, if anything, on the screen. And this is where someone loads in this malicious domain. It downloads that malicious Java applet and infects their computer. And because the attacks occur in stages, by the time they saw something manifest visually, they've already been infected. And they just happened to be on CNN's website when they saw that. So that's why we collect browser histories to determine if there was any malicious web pages the person were on. So again, the document.location is really dangerous because, again, it's going to redirect that person immediately to the malicious site. Sometimes the site is not malicious. It's just someone being silly, and they redirect you to something, visually that's not pleasing to you, or, something crazy. It doesn't matter. Again, with the iframe, because the height and width are 0, very difficult to detect on a web page, even though it still loads, however. And notice cross-site scripting is denoted XSS, not to be confused with CSS, cascading style sheets. Jay, do you have a question?
I have a question.
Yeah.
How are people able to get these tags onto your site?
Yes, a great question. For example, in a forum where you're typing a response to something someone's asking, you can inject that iframe or that JavaScript code into your comment. And then it's been saved into a database or XML file. And then when someone views your comment and loads that page, that comment interprets into
I see.
code.
And then how do you prevent that? Just with like input verification on the comments?
Yes, absolutely. I'll show you an example there in just a few minutes.
Okay. Thank you.
Absolutely. A quick way to test for cross-site scripting. First, there's a tool called XSSer, which you can use to scan your web applications. It'll look at your forums, and it will insert or inject some basic tags like we see down here, is bold, hi. If you see bold text, that means you are potentially vulnerable to cross-site scripting. I say potentially because, you may actually have input validation where the length of the string is minimal. So in this case, it'd be hard to inject something malicious with characters limited to 1, 2, 3, 4, 5, 6, 7, 8, 9 characters. However, you still have this problem where a user can inject arbitrary code. So again, incorporate this into your development and prior to production. Automation greatly reduces the amount of time you'd have to if you have a form with dozens of form fields, page with dozens of form fields, automation is the way to go. Arbitrary command execution, again, very, very dangerous because someone can simply use their web browser or an automated program like curl or Python or some other tool to run arbitrary commands. For example, here's an example where someone has a web page that allows you to ping to see if a host is up and running. And yes, these do exist, by the way. And some people will write code that talks to the OS. PHP has this function called system, which is used to run system commands. So we can see here that it passes in the IP address, and then it's going to ping it 4 times to see if it's up and running. And if so, you'll see the results on the screen, or they have some code running in the background that says up or down, however the programmer designs this. But the problem with this is that you can delimit commands, for example, on Linux with a semicolon. So this string that gets passed in by the user gets evaluated to what we see down here. So it's going to ping 4 times. And when that command is done, it's going to then run this command, cat exit password. And this is again where they may not see the results of this cat exit password. They may not see that. However, they can still do blind arbitrary command execution. And that's when they run a command that will send them an email. And in that case, they'll know that it's vulnerable. For example, if I was to pass in this, and then, you know, let's just do cat etc password, type that email, and then so I would type in this for the, you know, as a malicious string, and when I run this, it's going to ping 4 times this IP address, and then it's going to run the command cat exit password. It's going to send those results into the mail program, and then it's going to email it to me. And if I receive that email, then I know that this is vulnerable. So I can then start to make this more interesting by starting up a back door. If this was a Windows system, so what's going to happen is when I run this command, it's just going to hang there. It's going to the program is going to keep running. It's going to in a loop. It's going to hang because it's waiting for a connection. It's listening for a connection on port 8080. And when I connect to this server on port 8080, it's going to execute this shell and give me that shell. I will then have full control. Let me rephrase that. I will then have a shell or command prompt on that remote system as if I was sitting right in front of it. So if this was a Windows system and I passed in this malicious string and I connected to it, this is what I would see on my attacking system from anywhere in the world. And then I can start typing arbitrary commands. Taskless, see what programs are running. That user, see what users exist on the system. I can run any command I want to, all via a web application. Okay. As we see right here. And once you have this shell, what they then do is start crawling the file system. They start looking for hidden files. They can, whatever permissions the web user has, the attacker has the same permissions. So any files, any folders that they can peruse through, they can see that on that victim system. They can look at security configurations. They can look for sensitive documents. They can download more malicious tools. Just various things that they could do. And the files like .htaccess on an Apache web server, any file that starts with .ht is ignored by the web server, meaning it will not display the contents. However, if you have a shell or command prompt, you can look at the contents of this access file or the HT password file and then try to crack passwords. You can look at other scripts on the system. Maybe you attack this application and you start crawling the file system and you see that there are scripts that talk to a database. You can go find that database script to find out what the credentials are. And because you have a shell, you have a command prompt, you can manually start enumerating that database, for example. And it all comes from a lack of input validation. And there is a tool called Comics, which you can use to test for arbitrary command execution. And again, this is the tool that you can add to your development cycles. So while you're developing, just before you go into production, run this automated tool to ensure that any changes you made, especially, oh, I had to make a quick change, because these tools have automation built into it, it's so much easier to incorporate this into production to get results back pretty quickly. File inclusion vulnerabilities. This is when users are allowed to upload files. And this may be because of the type of work they do. Someone can upload an image file. Someone can upload a text file, CSV, spreadsheet, whatever. I mean, there are legitimate reasons to allow users to upload files based on, the type of work that they're doing and what the purpose is. However, you need to check to be sure the users are uploading what's expected. That's the important part. They can upload a JPEG, they can upload a Word document, Excel spreadsheet, but how are they using that application? How are they using those files once it's uploaded? So sometimes sites give out too much information. For example, you go to a website and it has a text file that it reads that shows you how to use the application. And you can see here, this PHP script has this variable file, and it calls on this file help.txt. Well, to an attacker, this is interesting because this typically means that there's a file somewhere named help.txt, and it could be in that current directory that this script is in, or it could be called from somewhere else on a file system. However, what an adversary would do is start to enumerate and see, can they access other files? Now, if you're not a Linux person, the reason why they go after this etc password file is because this file is readable by anybody on the system. It has to be. This is where user accounts, usernames, user IDs are located, and those are required to determine the permissions that people have before they can access files and folders on the system. So that's why you always see this etc password file. If you can get access to this, then you probably can get access to anything else that the web server user has access to. So in this case, they just start typing in arbitrary files to see if it will load, again, within the web browser. With the file inclusion, if the person is allowed to upload a file without proper checks, they can upload a malicious script. In this case, this is a PHP backdoor. It's a very simple backdoor, but a very effective backdoor. Because when they pass in, this is the variable that's passed to the script, CMD, just like file right here, except for to be CMD, equals whatever I tell it. In this case, CMD equals cat/etc password. So basically what I did is wrote this little PHP backdoor that uses this system function to execute an arbitrary command. So once again, any command that the web user can run, then this attacker can run as well. And this is where they run I can run a netcat command to get a backdoor, so I can get a shell. I can crawl the file system, all kinds of things. And more than likely, this is going to show up in your web logs. Or if you see repeated access to a file, let's say this file is called, oops, I'm sorry, I forgot to put a file name down here. So this file is called file.php, and you see repeat queries to it. It could be someone is doing something malicious. You want to take a look at this file. So in this case, whatever the user passes in is passed directly to the shell. Very dangerous. There's a tool called FIMAP, File Inclusion Map, which you can use to automatically test for file inclusion vulnerabilities. It's going to enumerate your web forms, and it's going to check to see, can it execute arbitrary commands? And once again, this is a tool that you can automate and put into your development development cycles, and also you can put it into production as well. And the last one here is XML, because some people don't use a database backend like MySQL, MS SQL, Postgres, whatever database you want to name, Oracle, etc. What they'll do instead is use a flat text file like XML, and typically think that it's okay, and it is. There's nothing wrong with using XML. The problem is when you don't properly filter what's coming into the form, then someone can inject their own malicious query, as we see down here at the bottom. This XXE right here tells XML it's looking for, it's going to load an external file. In this case, once again, our SD password file. And if you're on a Windows system, then you can try to enumerate a file in the, the C directory, like an INI file, for example. But it all boils down to all these injections, all these issues: SQL injection, cross-site scripting, arbitrary command execution, file inclusion, XML injection. It all boils down to input validation. And this tool here called Vega, it will test for XML injection. Once again, it's a tool that you can automate in your development and prior to production. So how do we prevent these? Validate input, escape all output. In my time doing incident response and secure coding workshops, I see programmers create elaborate regular expressions to filter data. I worked for a government agency that did a lot of work with scientific data, and they had to massage the data and the output so it's nice, it's nicely lined up and it looks pretty and everything. They would have elaborate regular expressions for that, but would have no filtering on the data coming in. As a developer, you know the type of data that should be coming into the application. You have to. You're developing an application. And what regular expressions do is allow you fine-grained control over what's allowed into the application. In this case, let's say it's a username, and the only letters allowed are alphabetic and numeric, because you may have a database backend and you're only allowing alphabets and numbers. It's alphanumeric, and it's between 3 and 8 characters. Well, with a regular expression, you can catch those characters. The thing here is you want to create them properly. In this case, don't want to use this expression because it'll evaluate to A to Z, 0 to 9, 3 to 8 characters anywhere in that string. It doesn't matter if it's the beginning of the string, end of the string, middle of the strings, scattered throughout the string. It's going to match this particular query. You want to include this caret, which is the beginning of the line, and you want to include this $, which is the end of a line. It takes the entire string and constrains it to between 3 and 8 characters. So now the username that comes in must match between 3 and 8 characters, A to Z, uppercase, lowercase, and 0 to 9. That's a filter that you can use to prevent numerous attacks, because you just cannot, input other characters. You can't input other an arbitrary length. It has to be between 3 and 8. It's a very easy, simple filter. And Jay is asking about cross-site scripting. Convert tags to their HTML entities, so that the less than symbol, for example, when it's stored in the database, is stored as &LT semicolon, its HTML entity. That way, when this is presented back to the user in the web browser, it's going to interpret it as a literal ASCII character, not as a tag. So they will see this because on the back end, it's stored in this format. So this is how it's stored in a database, and this is how it looks in the source code right here. But to the user, it's presented like this.
Wait, are you showing us a different screen? Because I only see the preventing input injections right now.
Oh, sorry. I thought I was sharing my whole screen. Okay, let me stop sharing. Share screen 1. You see that notepad screen? Okay, cool. Thank you. So yes, the database, when the user inputs this into the web form, the user inputs this, it's going to store it like this because you're converting these characters to that HTML entity. And then it's presented back to the user as a literal string of characters, not as a bolded high. Okay. I'm sorry, you probably didn't see my code before. This is what I was showing before, sorry. The arbitrary command execution. This is how the user would type in, the application is going to just hang, it's going to wait for a connection. And once I connect to port 8080 on my victim server, it's going to give me a shell that looks just like a Windows shell. It's going to look just like this. And then I can start typing commands. With arbitrary commands, I can start executing. That's why this is so dangerous. Thanks for catching that, Mel, sorry.
To do that, it was the last line that you had showed us, but you just deleted. What was the command for like doing that so that the you don't see the HTML code? Like, was there a specific command for that?
Oh, it depends on the language that you're using. So whatever the programming language you're using, you want to see how to convert tags to HTML entities. So in PHP, PHP has HTML special chars, and also has a function called HTML entities. But every language will have its own way of doing that. And this last point right here on this page is use the language's native function. Far too many times we saw people trying to catch all possible values and then someone would bypass it. When you use a native function, it's been validated and it's going to catch pretty much all bad input, but your language will have a way to convert characters to their HTML entities. When you're dealing with databases, the input is always good. Excuse me. But you want to try to use parameterized queries because it forces data typing. And with the parameterized query, when it's passed to the database, it's interpreted as a database query, a database string or integer, not as code. Because a single quote has special meanings to databases. A double quote has special meanings. But with the parameterized query, a single quote becomes a literal ASCII character. And if you do have to write a program that interacts with the operating system, again, check to see if the language has a native function to perform a task. So if you want to do a domain lookup, if you want to do open a file, see if the language has a native function for that. Don't pass the command to the shell and use cat, for example, the cat command, or type on Windows. Use the native function instead. It's much safer. And I'll provide a link to this presentation. I found some typos I need to correct first, but this has a link to a bunch of different languages validation libraries. So essentially, once you have this library of validation parameters, just include it in all of your programs. So you write the safe function once and use it multiple times in all your scripts. You don't have to keep rewriting it over and over and over again. And also, once you start using these types of validations for your code, you can then start writing programs to check to be sure that all of your code has these input validations. And again, that's pretty much a one-time script that you write, and then you run it on all of your programs. Take advantage of your programming skills to automate the processes.
Is this similar to like tests that you would make inside Node?
Yes,
Okay.
absolutely. Checking file length, size, map type, and extension. We've seen this many times. It's great to do this because it really does minimize and limit what users can do. But remember that checking file length, size, map type, and extensions, that's for your trusted users. You can't trust your users because you don't know who all your users are, especially when you have a public website. You're going to get scans all the time on your public websites. You want to check the file content. So if you have a PHP application, if you're writing, Python, check to see if what's been uploaded contains Python, PHP, Java code. If so, and it's not allowed, don't block it. Don't allow it. Throw an error back to the user. When a user uploading files, try to save it outside the web root. Because if the user notices that their files have been uploaded into a publicly accessible web directory, they can upload a backdoor and browse to that backdoor. Okay? Some people some developers change file names to hashes, which is good. But you want to add a salt value because if the attacker knows that you're using hashes, they can hash their file name too. And the hashes will always equal the same thing if you're using the same algorithm. So if I know you're using MD5 to hash your file and name it that, then I can, as an attacker, hash the file and come up with the same value and browse to it. What a salt does is adds, and the salt is secret. You don't tell them about what the salt is. The salt just adds some randomness to your hash. So MD5, and let's say my salt is the word pepper. I'm going to combine that hash file name with pepper. I'm going to come up with a brand new file name that I can't guess easily. Again, the salt has to be secret though. And web firewalls, they work for, Mod Security works on both IIS, Nginx, Apache, and different web servers. It's a good first line of defense. It can help mitigate many of the types of threats we just talked about. It'll filter out strings such as select, union, which are common for SQL injection. It'll look for words like cat. It'll look for words like password or cmd.exe, etc. And you can run this in audit mode first because sometimes developers write programs that contain strings that are known to be malicious and they may end up blocking their own application. So run this in audit mode first, and then you can move to enforcement mode once you fix any issues. And the audit is going to create a log so you can see what you need to change. And then when it's in enforcement mode, you're just going to drop those attacks immediately before it gets to your application. Any questions about input injection attacks? we got a few more attacks to cover.
So the input injection attack can only happen if you have some type of form, right?
Yes, if you have some way for the user to input data, yes. But
Even
again,
within
sorry.
oh, even within like search bars.
Yeah, I was just about to say, if you have a form, yes, but remember, with file inclusion, you may not have a form, but they can look to see how a file is being called, for example. You see, so in this case, they're using the data in the GET request to upload. However, there's a tool called Burp Suite, and it's a GUI program that allows you to modify the response and the request. So if it's not a GET request and it's using POST, you can use Burp Suite to make a request. You can modify the request before it reaches the web server. And if you look up Burp Suite and HTTP header modification, there's a lot of YouTube videos that shows you how that works.
This course works sweet.
I'm sorry, burp, like a belch. Burp Suite.
Oh, okay.
I have it in this presentation at the end as well. Broken authentication is when you have issues such as session fixation. It typically happens when a user's session logs out or it's supposed to time out, but someone can find that session, again, via the URL, where sometimes people put sessions and they can reuse that at a later time. So let's say it's now 12:50. If I logged out at 12:50 and I was able to steal someone's session, at 2 o'clock I log in and I authenticate as them, because that session is still alive, it's still available for me to gain access to a form or to an application. I one time had a consulting gig where someone was creating a community-based social media platform, and they asked me to do an audit of the application, and I did. And I didn't have access to the code. I just did the application, and they were making heavy use of hidden variables. And these are dangerous because when I went to do things like edit the user or edit my password, my user ID was in this hidden field. And they did a pretty good job of cleaning it up, except they missed it several times. So when I went to go change my password, I changed its value to something else. And it changed effectively someone else's password. So it's more, if you will, like a denial of service attack, because that person tries to authenticate and they can't because I just changed their password. If I can figure out whose ID this is and also their username, then I can authenticate as them because I just changed their password and I know their user ID. So my recommendation is just don't use hidden variables because they're too easy to modify. With Burp Suite, when you click request, Burp Suite is going to pause. It's going to show you the entire HTTP header, and you can modify any values you want to. And if this value was admin, it's even worse because that gets passed back to the system, to the server, I meant. I'm sorry.
So so I usually work with, I've been working with APIs, and we usually hide our API values inside of an env file, which is hidden from GitHub. Would that also be able to be hackable?
In general, no, because if you say env, that's server side, server side, right?
Mm-hmm.
Yes. Yeah. Server side is generally the way to go.
Okay.
Yes.
So that being hidden is different from the way this is being hidden.
Exactly. This is hidden on the form within the web page itself. Yes.
Okay.
But I do want to say with those variables and the end of those environment variables, be sure they're not being returned in a response. So using cookies, you don't want to store credentials in cookies because cookies are stored client side. And clients have access to all of their cookies and they can modify their cookies. And you can guess what they can do with that. They can just change the values to something arbitrary, send it back to the server to see what happens. If you have to store things server side with cookies, you want to encrypt it. You also want to make use of the domain tag so that you can restrict other websites from gaining access to someone's cookies. Because if there's no authentication, or I'm not going to call it authentication, if there's no restrictions on what domains can access the cookie, then any site you browse to can access it as well. So as a malicious user, I can redirect you maliciously to my website that steals your cookies to gain access to your application. So I can use cross-site scripting to get your cookies, for example. For the test broken authentication, very easy things to do. Log out, hit the back button. If you can still access to that application, move around in it, your sessions are not properly terminating. Close the browser, reopen it, see if you can gain access to that application again.
Is there actually like a way to fix that? Because I actually ran into that on this app I was making.
Yes. Were you using an API or were you using a native function? It's like,
I was using Google's authentication API, and through the tutorial that I was using, I was making an app with a tutorial, and every time I went back, I seen that it was still show that the user was signed in inside my console log.
oh, gotcha. When the user logs out, there should be a function in that logout script that will wipe out all session authentication. For example, you mentioned like those environment variables that you're setting. You want to delete all those, ensure those are all deleted in that logout script. So when it go back, there's nothing for it to attach to. And be sure there's not setting cookies, and be sure cookies have been deleted as well. And if you're using any other session or server-side authentication, be sure that those whatever API you're using, be sure it's being deleted as well. And that should be Burp Suite, not Burp Proxy. With Burp Suite, again, this is more of a manual thing where you can modify the requests and responses, which is very powerful. And what you can do is modify the request to see how the application responds. Modify the headers and then send it, see how your application responds to it. If you're using session information, I highly recommend you get it out of the get, the URL. Don't put it in the URL. Store it server side. Some URLs are very, very long. It has like session ID equals this long string. Get it out of there. Because if someone comes behind them and sees that session ID and they can replay attack, then they can potentially gain access to some very sensitive data. Mel, did that respond to your question?
Yes, thank you. That helped a lot. Thank you.
So just to reiterate, store credentials on the server side, not in cookies. And don't use hidden variables for credentials. Just don't use hidden variables. Don't use those. And I think there's a couple more. Insecure server settings. This is typically when you are in control of the web server itself, and without without proper training and web administration, you could potentially allow someone to see inside of a directory, and they can see file names. And if you have, text files, CSV files, documents, things that you don't want someone to see, they can still see those. Sometimes people will rename their files something -test dot, name your extension, PHP, PY, whatever. Or they may rename a file .txt, and that may contain sensitive information. For example, some people, one common practice is to put database credentials inside of a PHP file or Python file. And you may temporarily rename that file .py.txt because you're testing something. Well, a .txt file renders into a browser. And if they can see it's .txt, they can see those credentials in plain text. So if there's any files in your directory without the proper extension, you want to search for those. Ensure you're always using password protection on directories. And ensure that all files that should be password protected are within that directory structure as well. And most sites you go to these days, you'll notice that by default, redirect to SSL. So be sure that you're redirecting to SSL when you're using authentication and when you're transmitting any kind of sensitive information. And because of Let's Encrypt, it costs nothing to use SSL these days. Rep Suite, W3F, those, did I misspell that? I need to check that one. These are tools that you can use to automate, to look for common misconfigurations. I'm all about automation. Third-party software, when you're using APIs, you're using any kind of external libraries that are not native to the language or to the application you're using, you want to be sure those are maintained and updated. Just because something hasn't been updated since 2018 doesn't mean it's insecure, not supported. Inquire with the developer as to if they're still supporting it, just in case. My example is the library's TCP wrappers. I don't think it's been updated in probably 20 some years, but it doesn't need to be. It works. It's still supported, it just works well. It was intended to do one thing, and it does it very well. Ask the vendor, or subscribe to the vendor list, announcement list, so you'll keep up to date on when there's new versions or if they're addressing any known security issues. My pet peeve with software is bundled software. And I'm not picking on, well, I guess I am. Oracle is notorious for bundling in a bunch of software with their product. Java, this version, lib something, that version, but it's all bundled in to make that particular version in time work. However, if there's a vulnerability with this version of Java, well, your entire application is vulnerable. So what you want to find out from vendors is, what is their patch schedule to software when there's a vulnerability? And be sure you get that in the contract or in writing as well, so that they're going to take care of that version of Java so that your entire application doesn't become vulnerable. And finally, you want to log. Keep an eye on your logs. See what's going on. When you use these automated tools, it's going to create a lot of noise. But when you run these tools, look at your logs to see what type of events are being created. Use those programming skills to extract those, signatures from those web logs so that you can, review those on a routine basis. If you see someone probing for SQL injection, you can block them. Not just block them, but see what they're going after and just double check that program, double check that script, just to be sure you don't have a vulnerability that you may have missed. So blocking is one thing, fixing the script is what you want to look for, what you want to take care of. Don't trust user agents. When you run SQL map, by default, the user agent is going to say SQL map version whatever. When you run burp suite, it's going to say burp suite version whatever. You can always change your user agents. Don't let that fool you. Look for the signatures of the attack. And this link will provide you a list of software programs for different programming languages, and it will scan the code to look for common insecure functions. And sometimes some tools can inject code to see how it responds as well. So it's going to provide you a list of commercial and open source tools you can use to help you find those insecure functions. Because as we saw people learning about secure code, they would go in to upgrade their code and they may forget applications they have over here. And then we use a scanner and it finds those things for them. It's just one additional tool to make that job for you a lot easier. Kali Linux is a free virtual machine, and it has all the tools I just mentioned in this workshop. All the tools you need to help create an automated method for helping you write secure code. And this is your one-stop shop for writing secure web applications. It has lots of projects, has lots of tools, lots of documentation to help you with whatever language you're writing in for the web, and for also general software security as well. And a lot of the training shows you how these attacks work. So you can try it on these test systems first, and these test applications, and then you can test it on your own applications as well. So OWASP. There we go. That's my email address. If you have questions, or if you need assistance with anything, like help creating an automated testing process. Do you have any questions, comment, or conversation? Would you like to see more of this, like demonstrations or hands-on, where I demonstrate it, show you how it works, and then you try it yourself as well?
Sure, that'd be great.
Cool. Okay. And Jay, are you a programmer as well?
Sorry, what was that? Were you talking to me?
Yeah, are you a programmer as well?
Yeah.
Cool. What languages do you guys program in?
JavaScript.
Okay.
Mainly.
Yeah, JavaScript and a bit of Java and MySQL.
Okay. Yeah, no, Node.js has some input validation functions built into it that you can take advantage of.
Yeah.
All right. Well, thanks, folks. I appreciate you all attending.
Thank you. It was great. Thank you.
Yeah, thank you, Duane.
Yeah, thanks.
And I'll be sure to send along the slides in the presentation to everyone.
Great. What's going on?
Thank you guys. Have a great day.
Thanks,
Oh.
you too.
Were there other folks involved? I didn't see some folks.
Thanks, Mel. Okay, I'm gonna stop recording.